Greetings and welcome to Lesson 5.2, Rates and Unit Pricing. When you're out shopping, have you ever noticed that there will be multiple sizes of the same product? Let's say ketchup. There'll be a small jar, a small bottle, and then you'll have this really big bottle. Is bigger always the better deal? Is it cheaper to buy the bigger one than it is the smaller one? And when I mean by cheaper, I mean you're going to use all the product. You're not going to let it go to waste. You'll eventually use it all. Is it better to buy in quantity, in bulk, than it is to buy just a smaller object? Bigger packages and larger quantities are not always the more economical than buying the small. Are not more economical. Not always. Sometimes they are, but sometimes they're not. Let's say there's an item that I'm going to go buy and I may not need a lot of it, and it's a one-time purchase. It's not something that I buy on a regular basis. Then maybe even though the smaller one might, in essence, be more expensive for the item, then I would go for that because I'm not going to use a lot of it. If it's something like toilet paper, which I know I'm going to need a year from now, 2 years from now, 10 years from now, then maybe buying in larger quantities saves me money over the long term. So what is unit pricing? Well, let's take an example. Let's say that we're out of peanut butter and we want to go buy some peanut butter. And we go to the store, and the store has two sizes of peanut butter. Of course, the larger size, 48 ounces, costs more. There's just more of it, so it costs more. And the 18 ounce costs $2.79, and the 48 ounce costs $8.16. And I want to know which one is the better deal. What do I get for each of my dollars? How much does it cost, right? So here's what we're going to do. We're going to break this down into unit price, which means that it's going to be the cost per unit. And in this case, the units are ounces. Okay. It's a ratio of price to the size of it. $8.16 is to 48, and $2.79 to 18 ounces for the small one. If I figure this out, do this math, this is 17 cents per ounce. OZ, per ounce. And the smaller jar, if we do the math, turns out to be about 16 cents per ounce. So which one is the better deal? Well, the one that costs less per ounce. It's going to be the smaller jar. So in this example, the smaller one was actually the better deal. It was less expensive per ounce. Now, it doesn't mean that you need to walk around the store with a calculator in hand figuring it out. If you've ever really looked at the price tag, it generally will have a unit price on there that you can compare each of these. If it doesn't have it on it, then you can use this method to figure it out. It's kind of nice that they give you that per ounce. And I do that all the time. If I'm trying to figure out, well, do I want to buy the small jar? Do I want a big jar? I know I'm going to use it up eventually. I look at that unit price. I will also compare different brands by looking at the unit price. If I'm not brand loyal, I don't like a particular brand, they're all the same to me, then I'm going to look at the price and make a judgment call on which one is the more economical. In last lecture, we chatted about ratios, but when it comes to ratio, we were really kind of talking about the same object. We were talking about fruit to fruit, or free throws made to free throws attempted. We were still talking about the same kind of object. when we have units that are different, then we talk about it being a rate versus a ratio. In the next example, we're going to be talking about distance to hours. I can't convert hours over to distance, and I can't convert distance over to hours. They're just two different things. And when we want to have this ratio of distance to hours, it pops out being the rate of speed. Right? So we give it a full new name of its rate. It's still kind of a ratio, but it's a rate of speed. Okay? So let's try an example. If we travel 120 miles in 3 hours, then our average rate of speed can be expressed as a ratio of miles to hours. So miles to hours, and we traveled 120 miles in 3 hours. We are not going to express this as a fraction in the end. We're actually going to do this math. We're going to divide 3 into 120, so it will be 40 miles per hour. And you've probably also seen this as mph. We talk about mph a lot when we're traveling. All our street signs are 65 mph. You know, it's implied that it's miles per hour. If a train travels 125 miles in 2 hours, what will the train's rate of speed be in miles per hour? So again, rate of speed is going to be the miles to hours. Hours. Our miles are 125 miles to 2 hours. If we do this math, that's going to be 2.5 miles per hour. Okay. So we're just doing that math to come up with miles per hour. You can also think of it as, in our previous example, if we were to reduce this 120 to 3 miles to hours, we would have it come down to 40 miles per 1 hour. Since this is per 1 hour, it's per hour. It's kind of like that, having 1x versus just x, an implied 1 hour. Okay. Similar here, it's 62.5 miles per 1 hour. All right, let's try another example. A car travels 90 miles on 5 gallons of gas. Let's give the ratio of miles to gas as a rate of miles per gallon. All right, so if we travel 90 miles on 5 gallons of gas, then we're going to do this math. 5 goes into 91, or 9 ones, with 4 left over. 5 goes into 48 times miles per gallon. Okay, so if you get 18 miles per gallon, then you're probably driving maybe a truck or something. You're not driving, certainly you wouldn't be driving a little Honda Civic or Hyundai Sonata. They get better gas mileage than that. But it's something that you can figure out. You can time your car. Let's say you fill up your tank and your tank holds 14 gallons of gas, and you travel so many miles. Let's say you travel 280 miles. Then you can do that. 280 miles divided by the 14 gallons of gas. Hopefully you didn't run out of gas. And that would be 20 miles per the gallon. So you could figure out how many miles you can go on a tank of gas. So pretty useful if you ask me. Okay, let's go back to kind of the peanut butter question and go back to unit pricing. And unit pricing is just the ratio of price to the quantity. And we want to express that quantity as 1 unit. It could be 1 gallon, it could be 1 ounce, it could be 1 bag, it could be 1, I don't know, 1 ton. Any quantity that you have, you're going to get it down to one of those units. Suppose we have a 1 liter bottle of a soft drink, and it costs $1.19, whereas a 2 liter bottle of the same drink costs $1.39, which is the better buy. Now, without doing any math, you would expect, if they were the same cost per unit, that the price of the 1 liter bottle would be doubled for the 2 liter bottle. So without doing any math, we could figure out that the 2 liter bottle is the better deal. In terms of per unit, it costs less. But it may not be the better deal for you personally. Maybe you're not going to drink all 2 liter bottle, and it's for yourself to drink and you're not sharing it with anybody else. You have no fridge to put it back into. Therefore, maybe you go ahead and buy the more expensive 1 liter bottle, and that's the drink that you drink for yourself versus sharing it with other people. So let's set up this problem. The 1 liter bottle costs $1.19, and the 2 liter bottle was $1.39. So let's figure out the unit price of these. Well, the unit price of the 1 liter bottle is $1.19 to 1 liter, so it is kind of silly to say, but $1.19 per liter. For the 2 liter bottle, it is $1.39 for 2 liters, and therefore it's going to be, let's see, 2 goes into 13 6 times, 1 left over, 9, 5. So it's approximately 70 cents per liter. A big difference in price per liter. And you would make a judgment call on, did I only need 1 liter, or am I going to drink this later on so I can get the cheaper per unit 2 liter bottle? Where I see this a lot in stores is this variable size would be in the milk department. So let's say a supermarket sells low-fat milk in 3 different container sizes. And the gallon size is $3.59. The 1/2 gallon is $1.99, and the 1 quart is $1.29. And we want to know per gallon how much do each of these cost, so we can compare which one's the better deal. Well, per gallon for the gallon size is $3.59 per gallon. That was an easy one to figure out because it's already stated in gallons. The 1/2 gallon is $1.99. Well, I want this to be in a full gallon. So if 1/2 gallon equals $1.99, I have to make this 1 full gallon, so I'm going to multiply it by 2. 2 times 1/2 will give me 1. What I do to one side, I have to do to the other side. So 1 gallon will equal 3.98. Okay, so for the 1/2 gallon, for the 1/2 gallon size, it is $3.98 per gallon. Okay. For the quart, a quart is 1/4 of a gallon. So that is the 1/4 gallon size, is $1.29. And if I want to compare unit, I have to get this to look like a gallon. I'm going to multiply by 4. to both sides. So I'm left with 1 gallon will equal, let's see, 129 times 4, 6, 3, 8, 11, 4, that is 5/16 a gallon. So how does this help us? Well, we can see that the gallon size is 3.59 per gallon. The half gallon size is 3.98 per gallon, and the quart size is $5.16 per gallon. So economically, the gallon size is the least expensive. But if I don't need a gallon, and the gallon will go to waste, and I just need a little quart, then maybe I go ahead and pay the higher price per gallon and get the $1.29 quart size. So although per quart it's cheaper price for the milk, per gallon it's more expensive, and if I know that it's more expensive going in, I can make that educated decision on, do I need a quart or do I need a gallon? And if it's something like, hey, I can use the milk in my cereal the next day, I'd go ahead and buy the 3.59 gallon of milk, because overall it's less expensive per gallon. So that's it for this video. Until next time, be seeing you.